Sairam children, how are you all? Fine? Good. Welcome to online session. Mathematics Part 1, Algebra. We have already studied sets, the teacher has started. We'll continue from there. Chapter 1, Sets. Let's recall what we have studied earlier in previous session. Here some examples are given. Which examples can be called a set? Months in a year, brilliant students of the class, set of even prime numbers. Now first one, months in a year. Yes, it is a set. Why? Because here we can clearly mention the months. We can list them, January, February, etc. So we can define the objects. We can define it. We can write brilliant students. It's relative term. You cannot mention who's a brilliant student. I mean, brilliant in one activity may not be. So it is a relative term. Relative terms are not. So it is not a set. Set of even prime number. Which is a even prime number? Yes, 2. 2 is only, that is a even number, which is prime number. So here first one is a set. Third one is a set. Second one is no, because here the brilliant are also relative terms. So we have to keep in mind, a set is a collection of well-defined objects. Objects which we can define it properly. Now we have to write the sets, and there are methods of writing sets. We have studied, yes. First one is listing method, or we also call it roster method. Listing method or roster method. Here example is given. Set A is equal to, like elements are given 5, 10, 15, 20, 25. So here we have listed the elements, and the elements are separated by comma. And as you know how we write the set. Set, we use capital letter to write it. Then we take curly brackets to write the sets. Yes, second method is rule method or set builder method. Now in rule method or set builder method, what we do? We actually define the property of the variable. We define it. Like here, set A is equal to set of all x such that x is a multiple of 5 and is less than 13. So here the property is, or the variable is defined, that it is a multiple of 5 and is less than 30, because otherwise multiple of 5 you will have many infinite. So here the A example is that it is being listed 5, 10, 15, 20, 25. And you also know how to read when it is given in rule method, that set A is equal to set A is equal to the set of all x such that x is a multiple of 5 and is less than 30. Now we will be continuing from here. Types of sets. The different types of sets. First one is singleton set. Now, as the name suggests, singleton, single, a set consisting of a single element. There is only one element in this set. For example, set A is equal to 2. You can see there is only one element 2 in set A. Second set, empty set or null set. Now when we use the word empty, we say there is nothing, empty. So there is not a single element in the set. For example, set B is a set of all x such that x is a natural number between 2 and 3. Now is there any natural number between 2 and 3? No. So we have the number 1, 2. After 2 comes 3. Between 2 and 3, do we have any natural number? No. It means there is not a single element. It is an example of empty set. How to write that empty set? Set B. So we write B equal to in curly brackets. Put curly brackets, but there is no element in it. It is empty. Or we can also write B is equal to phi. This is a symbol given. This is a symbol of phi. It indicates empty set. So there is no single element, empty set. If there is a one element, singleton set. Next one, finite set. If a set is a null set or number of elements are limited and countable. So even you can say empty set, null set is finite. or if the elements are limited, we can count the elements, then it is finite set. Example, set C is equal to 1, 2, 3, 4, 5. We can say the first 5 natural numbers. But here the elements are limited. We can count. So it is an example of finite set. Now infinite set is an opposite of finite. If number of elements in a set is unlimited and uncountable, like set of natural numbers. When we say set of natural numbers, it goes on 1, 2, 3, 4, 5, never ending, goes on, continue. So it is uncountable. So set of natural numbers is an example of infinite set. And how we denote natural sets? Using capital letter N. So set N is equal to 1, 2, 3, 4. It's an example of infinite set. First one is finite because the elements are limited and countable. Next one is equal sets. As the word indicates, equal means when both the things are same. So two sets A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. So every element of set A should be in set B and element of set B in set A. Here's an example. Set A is equal to set A is a set of all x such that x is prime number and x is greater than 10 and less than 20. Now here it is given in rule method. X is a prime number. So we have to write the prime numbers which is greater than 10. Now which number is greater than 10 prime number? 11. Yes, 11 is prime number. 13, 17, 19. So all these are prime numbers. And when if you will list the set A also, you will get the same elements. So A is equal to B. Since set A and set B have the same elements. Every element is same. Now let's start with practice set 1.2. So you all are ready with your notebook? Maintain one notebook. Write in that. If no, quickly get your books and pen. First question. Decide which of the following are equal sets and which are not. Justify your answer. So first we are going to decide. For that we have to show the steps, the reasons. That is, justify. A is a set of all x such that 3x minus 1 is equal to 2. So here it is, equation is given. So first we have to solve the equation. 3x minus 1 is equal to 2. When you solve that equation, 3x is equal to, we have to take the negative to the other side of the equality. So negative becomes positive. 3x is equal to 2 plus 1. 3x is equal to 3. And we divide by then 3, x is equal to 1. So here, when you solve that set A, the equation, you get the answer which is 1. Set A is equal to 1. Set, that is, next that part is B is a set of all x such that x is a natural number but x is neither prime nor composite. So we have to find which is a natural number, neither prime nor composite. Which is that number, neither prime nor composite? Yes, it is 1. So set B is equal to 1. C is a set of all x such that x is an element of n. X is less than 2. Now here it is capital N given. It means it is an element of natural number. It should be a natural number. Now x is less than 2. Which is a natural number less than 2? 1. So set C is equal to 1. If you see, set A is having element 1. Set B is having 1. Set C is having 1. Since 1 is the common element in set A, set B and set C. Therefore, A is equal to B is equal to C. It is set A is equal to set B is equal to C. While writing, we write like that. A is equal to B is equal to C. So, we have to find out whether equal sets, showing the steps. Next question is, we have to decide whether set A and B are equal sets. Give reason for your answer. So, here also to find whether equal, you need to give the steps. Set A is equal to even prime numbers. Which is the even prime number? It is 2. As we know, only even prime number, that is 2 is the only even prime number. So set A is equal to 2. Set B is a set of all x such that 7x minus 1 is equal to 13. Here we are going to solve the equation part. Which is that equation part? 7x minus 1 is equal to 13. How we did the previous one? You have to show the steps. 7x is equal to negative 1 will go to the other side of equality. So it will become 13 plus 1. 7x is equal to 14. Therefore x is equal to 14 divided by 7. You get the answer? Yes, 2. X is equal to 2. It means set B is equal to 2. Check the set A. It is having the element 2. Set B, 2. Since 2 is the common element in set A and in set B, therefore set A is equal to B. How we write? A is equal to B. Next question. Which of the following are empty sets? Why? We know what are empty sets? Yes, what are empty sets? The set which does not contain any element, not a single element, then it is empty. First one. Set A is the set of all A such that A is a natural number smaller than 0. Now, which is the smallest natural number? 1. Smallest natural number is 1. Is there any natural number smaller than 0? No. So, there is no element in that. Set A is empty set. How will be writing? Set A equal to, put curly brackets, element in that. A is an empty set. Next. Set B is a set of all x such that x square is 0. Which number square is 0? 0 square is 0. It means x is 0. So we have to write B is equal to, write in curly bracket 0. Set B is 0. It means there is an element. One element is there. 0. Which is the whole number. So B is not an empty set. First one you see, A is an empty set. Here not an empty set. Even 0 is an element. It is an whole number, integer, rational number like that. Next question. Set C is a set of all x such that 5x minus 2 is equal to 0 and x is an element of n. So first what we are going to do? Yes, solve the equation. 5x minus 2 is 0. Now when you solve the equation 5x minus 2, 5x is equal to, your negative 2 will go to other side of equality. So 0 plus 2 is 2. 5x is 2. Therefore x is equal to 2 upon 5. Now 2 upon 5 is a fraction. Is it a natural number? No. So not an element. So not an element symbol is put. Put the element of element, put a slash, put an element. So 2 upon 4 is not an element of natural set. Because here when condition is given, x is an element of natural number. And smallest natural number we know is 1. It is not 2 upon 5. So C is equal to empty set. So how will write C equal to, put curly brackets. No element in it. It is an empty set. So understood what empty set? Empty set is a set which does not have any element. Next question is, write with reasons which of the following sets are finite or infinite. So what are finite sets? Finite sets are set when its elements are limited and can be counted. Infinite, opposite of that. And that the elements are unlimited, cannot be counted. First one. Set A is a set of all x such that x is less than 10. X is a natural number. So we have to write the natural numbers less than 10. So we list it. When we list it, we write set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Write in curly brackets how we write the sets. So we have listed that in the natural numbers, that is numbers less than 10 up to 9. So as the elements of set A can be counted. We can count them. So set A is a finite set. Now here it is asked that set C, the set of students of class 9 from your school. Now class 9, standard 9, we know the students. We know in each class students, roll numbers has been given. There's a record. It means we can count. We can count the number of students. So as the number of students can be counted, the elements are limited. So it is a finite set. Next. Set of apparatus in laboratory. You all go to laboratory, that is lab, yes, for doing experiments. So there the apparatus are given to do the experiments, and the lab in charge, lab teacher, she is having the record. Record is your apparatus. So as this apparatus can be counted, this record, it is a finite set. Now set of people from your village, like previous ones, student is in the class. Same way people in a village. So as we know, there's a record of death, birth, everything. So village, that is a Gram Panchayat, records everything. There's a record. So people can be counted. It is a finite set. A set of whole numbers. You know what are set of whole numbers? Yes, it is the numbers from 0, 1, 2, 3, 4. Now when we say smallest whole number 0, but can we say the greatest one? No. So this cannot be determined. It is never ending, continuous. Doesn't terminate counting. So we have to write as counting of elements does not terminate. It is an infinite set. Same way we can write that the set of natural numbers, integers, rational numbers, they all are infinite sets. Okay, now this is a new concept. Now these sets which we are writing in the listing method, even the set builder form, we can also represent them using a closed figure. So sets can also be represented by using a closed figure. A closed figure, it can be circle or like oval, circle, rectangle, square, triangle. It should be a closed figure and we can represent the set. You know who was the first one? Yes, he was British logician John Venn. He was the first to represent the sets by using the closed figure. So such representations are called Venn diagrams. Now here set A is given. It is in which method? Listing method. 1, 2, 3, 4, 5. And if I want to represent the same using a diagram, you can draw any closed diagram. And as we know, the set we use always a capital letter. So set A, that you have to write inside the closed figure. And then you list all the elements which are there right inside the set. 1, 2, 3, 4, 5 as it is given. So this is Venn diagrams. Now these Venn diagrams are very useful to understand and illustrate the relationship among sets and to solve sums based on that. So when we will be solving the sums based on this, we will be drawing these Venn diagrams and we can understand the relationship among the sets. Here is another example. Here set B is a set of all x such that x is greater than or equal to -10 and less than or equal to 0. X is an integer. See how it is given there, property is given, that is it is given in set builder form. And we have to represent it using a Venn diagram. So draw any figure. Here you can see it's in the shape of rectangle. So you can draw any closed figure, write the name of the set inside the figure. Then you list the items and write. Now x is greater than or equal to -10 and it is less than or equal to 0. Less than or equal to, so 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So this is shown by using Venn diagram. First one was listing method we have shown. Here set builder form. So sets can also be represented using closed figures which are known as Venn diagrams, and they are very useful for solving the sums. Okay, so what you are going to do now? Sums practice at home, the sums which are not covered in the exercise, or the same sums, do it once again, practice them. Till then, bye. Take good care of yourself. Next time, keep your pencil, books, everything ready. Maintain one book. So, stay home, keep learning. Sai Ram.